Horner's process, synthetic division process. In last class we discussed about division algorithm of polynomials. Okay, once I revise for you. Division algorithm of polynomials. When you divide f of x as a dividend polynomial with g of x, which I call divisor polynomial, then you will get some q of x, quotient polynomial, with r of x, which is remainder polynomial. So when you divide f of x with g of x, you will get quotient q of x and r of x, where f of x is dividend polynomial, g of x is divisor polynomial, q of x is quotient polynomial, and this r of x is remainder polynomial. Then according to division algorithm, what we have? We have that f of x is equals to g of x into q of x plus r of x. What it is? Dividend is equals to divisor into quotient plus remainder. And in this, we call it as a correct division algorithm statement only if the degree of this r of x is less than degree of g of x. And this division algorithm statement as well as this process of division helps us to find quotient and remainder if dividend and divisor are given. Once again I am repeating you. This division algorithm statement or this division process helps us to find quotient and remainder if dividend and divisor are given. In some other cases, among all these four, what are these four? Dividend, divisor, quotient and remainder. Among all these four, if any one polynomial is not known, then to find that unknown polynomial with the remaining three, we will use this statement of division algorithm or this division process. But sometimes to find remainder or quotient, the process of division is bit lengthy and complicated. So to avoid that lengthy process of division for some problems, okay, there another process is evaluated. That process is proposed by the mathematician Horner. So by his name we call it as Horner's process, and this is also known as synthetic division process. Okay, so synthetic division process helps us in a smart and simple way to find remainder and quotient, okay, without doing actual division. Once again I repeat for you everything. Actual division process or division algorithm statement helps us to find basically quotient and remainder, but sometimes that division process is bit lengthy and complicated. To avoid that complexity, to make it simple and smart, okay, Horner proposed a process which is synthetic division process, which is a substitute for the division process. And actually in the previous class we learned the way of division, and in this class I am going to give you the process and the way of synthetic division. Okay, this is bit different from the actual division process, right? Okay, and see the actual division process, this division process is applicable for any type of divisor. Once again I am stressing here, just pay attention. See, the divisor g of x may be any polynomial, that in the sense any polynomial in the sense that g of x may be linear, may be quadratic, may be cubic, any degree. See, this division algorithm and division is acceptable for any polynomials of f of x and g of x. This g of x is also may be of any degree, no problem with the division. Okay, maybe the problem bit lengthy, that's another matter. But coming to Horner's process, synthetic division process, to do this process, the divisor should be linear or the divisor should be quadratic. That in the sense what I am going to tell you is this synthetic division process is different depending on the divisor. If divisor is linear, then in one way we will move. If divisor is quadratic, in another way we will move. If divisor is cubic, in another different way we will move. Okay, so this synthetic division process is different is depending on the divisor. If the divisor is of first degree, one approach we have. If divisor is of second degree, another approach we have. If divisor is of third degree, another different approach we need to move. Okay, but the actual division process is same for all divisors, for the divisors of all degrees, no problem. Okay, so but to do problems in a simple way, we need to learn synthetic divisor process for linear divisor, linear factor, as well as for quadratic divisors only. More than that we don't need. Okay, so and that's why I am going to give you the simple way to find quotient and remainder using synthetic division process only if the divisor g of x is either of linear degree or of quadratic. Okay, so just have a look first. So to prove that synthetic division process, as well as to finalize the steps to finalize the process of synthetic division, there is a separate discussion, explanation and proof, but we don't need all that actually. Okay, that explanation is again completely depending on the actual division. Based on actual division, Horner proposed another simple way and he named it as Horner's process or synthetic division. Okay, the behind logic for this synthetic division process is again actual division. Okay, without going with the actual division, we will use synthetic division. Okay, to make simple of the problem. First of all, just look at the problem. 2x power 4 minus 3x cube plus 7x minus 5. So this is a polynomial. We need to divide that polynomial with x minus 2. Okay, for suppose in a general way, usual division process, as they given, this is 2x power 4 minus 3x cube plus 7x minus 5 is the dividend, and we need to divide that dividend with the divisor x minus 2 and we need to move. This is the actual division. Once you observe, this given polynomial, dividend polynomial is of 4th degree, whereas this divisor polynomial is of 1st degree. As I said, we are going to learn the synthetic division process only for the divisors. That in the sense, divisors means this position. Okay, only for the divisors of 1 degree as well as of 2nd degree. That's it. So this is the 4th degree, this is the 1st degree. When you move with the actual division to find remainder and quotient, it requires at least 4 steps of division, because this is the 4th degree. After one step, you will get 3rd degree. After second step, you will get 2nd degree. Already we discussed the way of division in the previous class. Okay. So step by step, you need to reduce the degree of the dividend. At the end, you left with the remainder. So it needs 4 steps actually. But this synthetic division process directly gives you the quotient and remainder in one step. So how to proceed? So as a process, first of all, you need to list out the coefficients of the polynomial. Coefficients of the polynomial: 2, minus 3, 0, 7 and minus 5. Just observe. You need to list out the coefficients of the polynomial in the decreasing order of the powers. X power 4, coefficient is 2, x cube, coefficient is minus 3, x square is actually missed here. Since x square is not there, you need to consider its coefficient as 0. So 0 and then x coefficient 7 and then constant minus 5. Okay, list all the coefficients of the terms of the given polynomial in the decreasing of their powers. And then, yeah, as a notation of synthetic division, use this symbol, use this notation. Okay, just like this. Okay, and since x minus 2 is the divisor, you need to take number 2 here. Once again, I repeat for you. Since x minus 2 is the divisor, you need to take 2 here. Okay, right. So these are the coefficients. This is 2. As a process, initially you need to take zeros here. Okay. Initially you need to take zeros. 0 here. Okay. 2 plus 0 is 2. Just observe the approach. 2 plus 0 is 2. And then 2 into 2. Multiply this number with this. 2 into 2 is 4. Again add column wise. 4 minus 3 is 1. And again multiply this 1 with that 2. You need to write a 2 here. And then add column wise. 0 plus 2 is 2. Again multiply this 2 with that 2. It will give you 4. And then 7 plus 4 is how much? 11. And then 11 into 2 is how much? 22. So 22 minus 5 is how much? 17. Okay. At the end, you need to consider this 17 as the remainder. If you go with the actual process, then also you left with that 17 as the remainder. Okay. So once again I explain for you the process of synthetic division. Okay. Yeah. Once again I explain for you, just have it. First of all, you need to list out the coefficients in the decreasing order of these powers, like 2, minus 3, 0, 7, minus 4. And then since x minus 2 is the divisor, you need to take 2. It is x minus 2, take 2. Okay. Pay attention, right? And as a process, first of all, you need to write 0 here. And every time you need to add column wise. And every time multiply this number with the 2 right here. See, this is 2, and first of all you need to start with this 0. 2 plus 0 is 2. 2 into 2 is 4. Add column wise 1. 1 into 2 is 2. Add column wise 2. 2 into 2 is 4. Add column wise 11. 11 into 2 is 22. Add column wise, that is 17. At the end, you need to treat this 17 as the remainder. And that 17 is the remainder. See, let us look at these numbers. 2, 1, 2, 11. That 17 is the remainder. This 2, 1, 2, 11 will give you the quotient. Okay. So this part represents quotient. That part represents remainder. Do actual division, but it needs 4 steps. At the end of 4 steps, again you will get same 17 as the remainder and this part as the quotient. See, how can you write the quotient using these numbers? Again, these numbers will represent the coefficients of the quotient. That in the sense, yeah, constant x square, x cube. So 2x cube plus 1 into x square plus 2 into x plus 11. This 2x cube plus x square plus 2x plus 11 will represent quotient polynomial. This 17 will represent remainder polynomial. At the end, what we need to conclude? This is dividend polynomial. This 2 will represent divisor polynomial. This will represent quotient polynomial. That 17 will represent remainder polynomial. And this synthetic division is very simple, and in one step directly we are getting quotient and remainder without moving with the 4 steps. So finally, what I have a chance to write, this is dividend, divisor and quotient, right? So therefore from this, actually I have no space here, that's why I am using this. Therefore 2x power 4 minus 3x cube plus 7x minus 5 dividend is equals to divisor. What is that? X minus 2 into quotient. What is this quotient? 2x cube plus x square plus 2x plus 11. Quotient plus remainder. What is that remainder? 17. Dividend is equals to divisor into quotient plus remainder 17. So this is what division algorithm statement using synthetic division process. You need to identify the process, okay? You need to analyze it, and I have some more problems to discuss. Just have a look and then I will discuss the next one. Next problem. X power 2020 plus x plus 1. This is the polynomial, and we need to divide that polynomial with x plus 1. Again, the divisor is linear. If it is linear, then only the synthetic division process helps us. And this is the polynomial. You just look there, x power 2020 plus x plus 1. This polynomial is of 2020th degree. Okay, this is of 2020th degree, this is of first degree. To find quotient and remainder, if you use actual division, you need to do 2020 steps. Actual division needs 2020 steps to mention remainder and quotient, but synthetic division needs only one step. But since it is of degree, highest degree, you need to do in a logical way. So x power 2020 plus x plus 1. X power 2020, coefficient is 1. First of all, list all the coefficients, right? X power 2020. Okay, x power 2009, we don't have, right? So first of all, this is the actual notation. What I am going to represent for you is x power 2020 coefficient, x power 2019 coefficient, x power 2018 coefficient. Likewise, if you proceed, coefficient of x square, coefficient of x, and then constant term. Okay, now just look there. What is the coefficient of x power 2020? Here the coefficient of x power 2020 is 1. Coefficient of x power 2019 is 0. coefficient of x power 2018 is 0. Likewise, if you proceed, coefficient of x square is again 0. Coefficient of x into 1, right? 1. Constant is again 1. Constant is also 1. So these are the coefficients. Now since we are dividing with x plus 1, you need to take minus 1 here. As I said, if it is x minus 2, take 2 here. If it is x plus 1, take minus 1 here. So first step. In first step, what you need to take? You need to take first 0 here and then go with the process. Add column wise. 1. 1 into minus 1. Minus 1. Add column wise. Minus 1. Minus 1 into minus 1. 1. Add column wise. 1. And then 1 into minus 1. Minus 1. Add column wise. Minus 1. Likewise, we need to proceed. And if you observe, see, for x power 2019, the value here it is minus 1. For x power 2018, the value it is 1. For odd degree minus 1, for even degree 1. Since x square is of even degree, you will get 1 here. Okay. And since it is 1, 1 into minus 1 is minus 1. Again 1 minus 1, which is 0. Okay. And since it is 0, 0 into minus 1 is 0. And 1 plus 0 is 1. Just observe it. Okay. Every time you just add column wise and then you just multiply with the previous one. So finally what you will conclude? Finally, this 1 just indicates as remainder. This is remainder. And this part will represent what? Quotient. So since the given one is a polynomial of degree 2020, then it will be a polynomial of degree 2019. So x power 2019, this one represents x power 2019. Minus 1 represents minus x power 2018. Plus this one represents x power 2017. This minus 1 minus x power 2016. Plus and so on. At the end, see, 0 will give you the constant, but this is 1, so that represents plus x. See, this total thing, just have a look. This total thing is the quotient q of x, and this 1 is the remainder r of x. This is dividend polynomial, and this is divisor polynomial. So, just by using synthetic division, in one step directly we are getting quotient as well as remainder. But actual division won't give you the remainder as well as quotient in one step. It needs 2020 steps. But synthetic division in one step you are getting. So this is synthetic division for linear factors. And then I have synthetic division for quadratic factors I will discuss. First of all, have a look. So synthetic division for quadratic factor. Next one. Because first of all, you just look at the problem. This is the polynomial we need to divide. This is dividend polynomial, and we need to divide with this x square plus x plus 2. X square plus x plus 2 is a quadratic factor. See, this is the divisor. Now the divisor is of second degree. As I said, actual division process is acceptable for any divisor, but synthetic division process is different from depending on the degree of the divisor. For linear factor, one approach we have. For quadratic factor, we need to go with the other approach. For suppose, if we are dividing a polynomial f of x with x square minus ax minus b. First of all, I am giving you the general process. For example, we are dividing that f of x with this x square minus ax minus b. Then, when you convert it into the process of synthetic division, first of all, in the same way, you need to list out all the coefficients of f of x. See, these are the coefficients of f of x. And then here you need to proceed in two steps. Okay, look at this. If it is x square minus ax minus b, identify the coefficients, write a here and b here. I am mentioning the synthetic division way. Okay, this is f of x, write a here, write b here. And then you need to take 0, 0, 0. In initial stage, you need to take 3 zeros here. And again, as it is, go column wise addition and then multiply. At the end, last step, okay, in this last step also you need to take 0. You will get two numbers at these two positions, and these two will represent the remainder. These two will represent the remainder, and all this part will represent the quotient. This is the general picture of synthetic division for the quadratic factor. Now I am going to apply this picture for this two polynomials as I will do. Okay, first of all have a look the given polynomial and then compare the divisor with this x square minus ax minus b. Write a here, b here and take 3 zeros here. These two will represent the remainder and this part will represent the quotient. Okay, now go with the problem. F of x is this given problem and x square minus ax minus b is just given by x square plus x plus 2. Since it is x square plus x plus 2, what we need to take in the place of a? In the place of a we need to take minus 1. As well in the place of b we need to take minus 2. Okay, this is minus 1, this is minus 2. Just for your convenience I mentioned this. So but as a problem you need to do, take it as minus 1 and minus 2. That's it. Now f of x. Here you need to list out the coefficients. What are the coefficients actually? 2x power 4. So 2 minus 3x cube and then 4x square and then minus 2x and then 1. So these two must be zeros and this is also 0. Okay. Now what we need to do? Add column wise. This is 2 and then multiply this 2 with this minus 1. It gives you minus 2. 2 with minus 1. Okay. And then minus 3 minus 2 0. If you add that is minus 5. And then to write these two numbers, minus 5 into minus 1 is 5. 2 into minus 2 is minus 4. Add again these numbers. That is 5. Again 5 into minus 1 is minus 5. Minus 5 into minus 2 is plus 10. Okay. And then 10 minus 7 it will give you as 3. Okay. And then see this 3 comes into the remainder part. So no, don't multiply this 3 with minus 1. You just multiply this 5 with minus 2 which is minus 10. And then add, you will get it as minus 9. Now see this 3 minus 9 will represent remainder part and here the remainder is 3x minus 9. What is the remainder? 3x minus 9. And these three numbers will represent quotient. See this is of 4th degree. We are dividing with 2nd degree. Again you will get only 2nd degree. So the quotient part here it is simply nothing but 2x square minus 5x plus 5. This is synthetic division for quadratic factor. Okay. Have a look. Once again if you need I will explain for you. Right. You just erase these numbers. I am erasing this. I am erasing this. Okay. You just have a look. Okay. So first of all, these are the coefficients of the given polynomial. 2 minus 3, 4 minus 2, 1. That's it. And these two are the numbers when you compare the divisor with x square minus ax minus b. A is minus 1, b is minus 2. And then these 4 places should be zeros. You need to start with that. Okay. Because we are following certain steps, we are calling it as a process. It's not, okay. Right. And then add column wise. This is 2. Then 2 into minus 1 is minus 2. Add column wise. This is minus 5. And then minus 5 into minus 1 is 5. This 2 into minus 2 is minus 4. Add column wise 5. And then this 5 into minus 1 is minus 5. This minus 5 into minus 2 is 10. Add column wise. This is 3. And then since this 3 comes into the remainder part, don't multiply 3 with minus 1. But multiply 5 with minus 2, that is minus 10. Add column wise, minus 10. 3 minus 9. Because it is of 2nd degree, the remainder should be first. As we know, remainder is always less than divisor degree. Okay. So 3x minus 9 is the remainder. And this 2x square minus 5x plus 5 is the quotient. Again, as we discussed in the previous cases, at the end we have dividend, divisor, quotient and remainder. Therefore, I will write it like this. 2x power 4 minus 3x cube plus 4x square minus 2x plus 1 dividend is equals to divisor. What is the divisor? X square plus x plus 2 is the divisor into quotient. What is the quotient? This 2x square minus 5x plus 5 plus remainder. What is the remainder? 3x minus 9. So these two are equal. Okay. So this is divisor, this is quotient and that is remainder. Without actual division, just we are using synthetic division. Sometimes this synthetic division process for quadratic factor also helps us. Okay, have a look, and I have one more problem here to do. Okay, have a look. So just look at the next problem. Here we need to divide 3x power 4 minus 8x power 5 plus 4x cube minus 3x square plus 2x plus 1 with this divisor x square minus x minus 1. We need to compare the divisor with x square minus ax minus b, as I said. So x square minus ax minus b. So minus ax minus x. So what is here? A is 1. Write 1 here. Minus 1 minus b. What is b? B is also 1. Write 1 and 1 here. And as a process of division, you need to take these two positions as zeros, and this position is also 0. And already I listed all the coefficients here. See, what are the coefficients? 3x power 7, so 3, and then x power 6 term is not there, so 0. Minus 8x power 5, minus 8, x power 4 is not there, so 0. And x power 4, then x cube, so 4, x square, minus 3, x 2, and then constant 1. So this is the basic structure, and we need to move with the process now. So how can we proceed? As I mentioned, add column wise. This is 3. Multiply this 3 into 1. That is 3. Add column wise. This is 3. 3 into 1 is 3. 3 into 1 is 3. Add column wise. Minus 2. Minus 8 plus 6. And then minus 2 into this one is minus 2. And then 3 into this one is 3. Add column wise 1, and then this 1 into 1 is 1, and then this minus 2 into 1 is minus 2. 4 plus 1, 5 minus 2 is 3, and then this 3 into 1 is 3, and then this 1 into 1 is 1. Add column wise, you left with 1, and then 1 into 1 is 1, and then 3 into 1 is 3. Add column wise, that is 6. So then you just left with two numbers, so you need to take these two numbers represent the remainder. So since 6 is already here, so multiplication of 6 with 1 is not allowed, so take it 0, and then multiply this 1 with this 1, this is 1. Add these two, you will get 2. So just have a look. So at the end what will happen? This 6 and 2 will represent the remainder. So what is remainder? Remainder is 6x plus 2 if you go the division. And all this part will represent the quotient. And what is the quotient here? See, since the given polynomial is of 7th degree, the quotient is of 6th degree. No, not 6, because it is quadratic, right? So this is 7, this is 2, this should be 5. So 3x power 5 plus 3x power 4 minus 2x cube plus x square plus 3x plus 1. Observe this, 3, 3 minus 2, 1, 3, 1. 3, 3 minus 2, 1, 3, 1 are the coefficients. X power 5, x power 4, x cube, x square, x and 1. This is quotient, that is remainder, this is dividend, it represents divisor, and that is the synthetic division process without going with the actual division. Have a look. So at the end, in this class we discussed about the synthetic division process for linear factors and quadratic factors. These two are enough just to solve many problems. Okay.